See, the diagram shows a circuit that includes two batteries. As you can see here, it's 18-volt battery and this is the 20-volt battery, each with negligible internal resistance. What is the reading on the ammeter? So see, again, what we can do, just first take only one battery, then analyze the circuit, then take the second one, analyze the circuit, and then superimpose them, right? So let us start the calculation. Is it okay? So now
Yes,
I'm considering this 18-volt battery only. So this 20-volt battery will be now short circuited. Is it okay? So now analyze this complete circuit. What it should be? See, then now 4 ampere and this 8 ampere becomes in parallel. Now you can see this 4 ampere becomes parallel to 8 ampere, right? So its R equivalent should be, it is 4 into 8 upon 4 plus 8, that is 4 into 8 upon 12. So it should be 8 upon 3 ohms, right? So how much total R equivalent? So the total R equivalent should be this 8 upon 3. This will be in series with this 20 ohm resistor. So you should add this 20. You may convert it into like fraction. So it should be 68 upon 3 ohms. So how much current I should have in this case? I equals to V upon R. So V is 18, R is 60, R is 68 upon 3. So R is 68 upon 3. This 3 will go in upside. So how much it will be? 18 into 3. 18 into 3, that is the 54 divided by 68. So it should be 0.79411 like this. Is it okay? This much ampere. And what should be the direction? See, current should be flow in this direction. So it is coming in this direction. Then, yeah. Okay, fine. Now, what I will do, I will take another one. So in this case, this 18 volt will be now short circuited and this 20 volt comes into the picture. Okay, so what will happen now? Let me remove all these things. Now my current will start flowing in this direction. So it will come here. Now you can see that this 4 ohm and 20 ohm are in parallel. Are you getting this? This 4 ohm and 20 ohm are in parallel. So first find 4 parallel with 20. So its equivalent should be 4 into 20 upon 24. So it's
question. Yeah. I thought you would add the 4 and the 20.
Sorry.
Sir, I thought you would add the 4 and the 20. They're not exactly parallel, are they, sir?
See, why not parallel? See, I am considering this ammeter as an ideal ammeter. Yeah, Sanupa, please discuss. You are your concern is that your ammeter, due to ammeter, you cannot take these two as a parallel, right?
Yes, sir.
But we are taking this as an you can say ideal ammeter, and you know, or just see, basically your question wants to know the direction in this branch, right? Direction or the magnitude of current in this branch. So suppose there is nothing there is nothing ammeter. You know, these instruments do not change our reading. So we just have to find ideally we have to find what's going on in this branch. So ammeter will read that thing only, right? We are not considering this as a practical ammeter. We are considering this as a ideal. And ammeters has a very low resistance. Are you getting my point? An ideal resistance. Yes, an ideal ammeter has zero resistance. An ideal ideal ammeter. Do you know this? An ideal ammeter has very negligible resistance. Yeah. So you can treat this as a 0 ohm. Are you getting my point? So it means now they are in parallel. Is it okay now? So yeah. So yes, this should be 20 upon 6. So you should have 10 upon 3 ohm. The parallel of these two. So the parallel of, now I am considering this now. The parallel of these two should be 10 upon 3. You may have like this, right? So this is the 10 upon 3. So how much total resistance I have? How much total resistance I have? This 8 ohm plus 10 upon 3. So please make it a like fraction, into 3 into 3. So it should be 8 3 are 24 plus 10, 34 upon 3. This is the total resistance. So how much the total current? V upon R. V is 20. R is 34 upon 3. So it will go in the numerator. So let me solve. 60 upon 34. 60 upon 34 is 1.7647 like this. Is it okay? Now this is what? This is the current which is flowing in this direction. This current will come here. This current will come at this junction. After that, it will get divided into two parts. Isn't it? One part will go here. Isn't it? See? And one part will go in this direction. Is it okay?
Yes, sir.
In this manner, it will pass through here, 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 and both the current will meet at this junction and return to the
Yes, sir.
battery correctly. So now I'm interested in that current which is going in this 20 ohm. Why? Because that will be readed by this ammeter. I have to find the current in this branch. So now I am interested in this 20 ohm resistor, right? So do you know the current division rule? So let me find first. So I dash, I'm writing this as I dash. It means the current flowing in this 20 ohm resistor. So I should have, see, Sanuka, are you there?
Yes, sir.
See, so I think you know this, Ohm's law is V equals to IR. In the parallel reading, in the parallel connection, my voltage is same. So current and R are inversely proportional. I can write I is inversely proportional to R. So suppose I want to find the current for the 20 ohm. So I should write the 4 ohm in the numerator. So it's the inversely proportional. So it should be 4 upon 4 plus 20 times the total current which is coming at this junction or which we want to distribute. That is, I think we should take this as a complete one, that is 60 upon 34. I'm taking this complete one so that I do not have an approximation error, right? So I'm taking this
Okay.
60 upon 34 as a whole. Otherwise, I have to take a long values here. So what I should have 4 upon 24 into 60 upon 34. So I should have 4 6 6 10. So I have 10 upon 34, right? And let me find the value. 10 upon 34. It is coming out as 0.2941, like this, in this direction. Initially I have represented this as a black one, as you can see here, this black arrow. Initially this was in this direction, and right now this is in this direction. So what I should have, I should subtract both the current. So what was the initial value of current? See, the initial value of current was this 0.7941. Or see, we can, if you do not want to take the approximate error, so just take this value 10 upon 34, and here you should take the value of this 54 upon 68, right? Or we can simplify it a little bit. We should go in the fraction only. Let me do, no, there is nothing yeah, something is divisible here. Just simplify this. Are you getting what I'm doing? I'm avoiding the approximate error,
Yes, sir.
approximation error.
You're finding the resultant current.
Yeah, I'm avoiding that approximate error. Okay, so now I will simplify it a little bit. So it is 2 nines, 2 threes, 4. So this is coming as 27 upon 34. Okay, so now I have to subtract. This is approximately 0.79, and previous it is 0.29. So lower one is higher, so I should subtract. See, this 27 upon 34 minus 10 upon 3. I think it was 10 upon 3. Yeah, no, it is 10 upon 34. Sorry, it is not 10 upon 3, it is 10 upon 34. So I should write 10 upon 34.
Oh,
So
yes, you did.
we
You
are
did
getting 17
0.5
upon
amperes.
34. That is exactly 1 upon 2, right? So the answer should be 0.5. See, if you see, if you take the approximation error, then you will not get your correct answer, right? So that's why we have applied here mathematics as well, that we are avoiding,
Hmm.
approximation at each and every step, so that we are getting the correct answer. And the whole concept is the same. When you have two batteries and you have the situation like this, just apply your superposition theorem. Just ignore the first battery, analyze the circuit, keep all the values right separately, and do for the second battery as well. For removing the battery, what you have to do, just short circuit them. Suppose we have the current source, then to removing the current source should be taken as a open circuit, but for the voltage source it should be short circuited. Are you getting my point?
Yes, sir.
Very good.